Hello everyone and welcome to Fortinac Administration course. First of all, I'd like to thank you for joining this course. My name is Mohammed Fauzi and I'll be your instructor throughout this course. Whether you are a network engineer, security administrator, IT manager, system integrator, or cybersecurity professional, this course has been designed to help you to understand and master Fortinac from the ground up. During this course, we will not simply learning where to click in the UI. Instead, we will understand how Fortinac works, why each feature exists, and how to deploy successfully in real enterprise and in industrial environment. Throughout this course, I'll share practical examples, best practice, and deployment tips that I have learned from the real-world implementation. By the end of this course, we will have the knowledge and confidence to deploy, configure, administrate, and troubleshooting Fortinet solutions. So let's begin our journey. Before we discuss Fortinet itself, let's first understand what the course covers. This course provides a complete foundation for learning Fortinet administration. We will start with a basic concept and gradually move toward advanced deployment and administration. As you probably know, today's enterprise network contain much more than desk computers. Organizations now have laptops, mobile phone, printers, IP cam, Internet of Things devices, wireless devices, industrial controller like PLC, HMI, and many other endpoint types. First challenge facing every security team is the visibility. You simply cannot secure devices that you don't know exist. Fortinet solves this challenge by automatically discovering every connected devices, identifying it, classifying it, monitoring its behavior, and controlling its access to the network. Throughout this course, we will learn how to deploy Fortinet in an enterprise campus, data center, branch offices, and industrial OT environment. We will also learn how Fortinet integrates with the rest of Fortinet security fabric to automate security enforcement. Now let us see what this course is intended for. This course is intended for security engineer, network administrator, system administrator. If you are a network administrator or a network engineer, you will learn how Fortinet provides complete visibility into your switching and wireless infrastructure. If you are a security administrator or security engineer, you will discover how Fortinet becomes an important component of zero trust architecture by verifying both users and devices before allowing network access. Cybersecurity analysts will learn how to detect root devices, investigate suspicious activity, and automate incident response. Industrial network engineer and OT security engineer will learn how Fortinet discovers and protects unmanaged industrial assets such as PLC, HMI, SCADA server, and other operational, technical, and technology devices. This course is also valuable for Fortinet partners, system integrators, technical consultant, solution architect, and IT manager who design and manage secure enterprise network. In short, if you are responsible for managing or securing a network, this course will provide a valuable knowledge about it. Before starting the technical topics, let's quickly review the recommended prerequisites. Don't worry if you have never worked with Fortinet before, this course starts from the fundamentals. However, having some networking experience will help you to learn much faster. You should already understand basic networking concepts such as TCP/IP addressing, switching, routing, VLANs, and subnetting. You should also be familiar with the common network devices like switches, wireless network devices, wireless controllers, and firewall. Basic cybersecurity knowledge, especially authentication and access control, is recommended because the concepts are heavily unused throughout this course. If you have previously worked with a FortiGate firewall, that is definitely an advantage since FortiGate integrates very closely with the FortiGate and other Fortinet products. Finally, basic troubleshooting skills will help you during the practical demonstration later in this training. Don't worry if you don't know everything yet, we will explain each concept as we progress. Now let's see exactly what you will be able to do after completing this course. After completing this course, you will be able to understand the complete Fortinet architecture and the role of each system component. You will learn how to deploy Fortinac and configure it to achieve complete network visibility. We will learn how Fortinac discover endpoint, profile devices, classify assets, and continuously monitoring network activity. You will understand how to configure authentication method and enforce security network access based on user identity, device type, location, and security voucher. We will also configure network access policies, dynamic VLAN assignment, and automated policy enforcement. Later in this course, you will learn how Fortinet integrate with switches, wireless controller, FortiGate, and other Fortinet security fabric. We will cover also root devices detection, compliance enforcement, troubleshooting techniques, monitor logging, and best practice for enterprise deployment. By the time you complete this course, you will be ready to administer Fortinet confidently in a production environment, and you will also have a solid foundation for the Fortinet administration certification. Now that you know the objective, let's take a quick look at the roadmap of the entire course. In Module 1, we will build a foundation of every Fortinac administration need. We will begin by understanding what Network Access Control or NAC really is, why organizations need it, and the challenge it solves in modern enterprise and industrial network. Next, we will study the Fortinac architecture and its main component and understanding how they work together to provide visibility and control access through the network. After that, we will discuss deployment model and sizing consideration, helping you to determine the right Fortinet solution based on the size and complexity of an organization. We will also cover the initial installation process, licensing, dashboard navigation, and finally how to perform a backup and restore operating system to protect your Fortinet configuration. Once we have established the foundation, we will move to Module 2. Module 2, achieving network visibility. Visibility is the heart of every network access control solution. Before you can secure a network, you need to know exactly what is connected to it. In this module, we will explore the different devices discovering methods supported by Fortinet, learning how Layer 2 and Layer 3 visibility work, understanding device profiling and fingerprint techniques, and discover how Fortinet automatically builds a complete inventory for a network access. We will also examine how Fortinet discover IoT and OT devices, which are becoming increasingly common in enterprise and in industrial environment. By the end of these two modules, you will understand how Fortinet sees your network and why accurately visibility is the foundation of effective security. Once Fortinet discovers every device, the next step is determining which device should be trusted and which one should not. This exactly we will cover in the next module, Module 3. On Module 3, we will focus on one of the most important security functions of Fortinet, identifying unauthorized or rogue devices. Every organization eventually faces the problem of unknown devices appearing on the network. These could be unauthorized laptop, personal devices, unmanaged IoT equipment, or even a malicious system intentionally connected by an attacker. In this module, we will learn how Fortinet detects the rogue devices using multiple discovery technique. We'll discuss the difference between managed devices, known devices, and completely unknown endpoint. You will also learn how Fortinet classifies hosts automatically and places them into logical categories based on characteristics such as operating system, manufacturers, communication behavior, and device type. This classification process is essentially because security policies rely heavily on accurate devices identification. By the end of this module, you will understand how Fortinet continuously monitor your network and immediately recognize when something unexpected appears. After identifying devices, the next logical step is deciding how those devices should access the network. This brings us to the logical network and the state-based control. In Module 4, we will explore how Fortinet organizes and secures the network using logical network. Rather than managing security on a switch at a time, Fortinet allows administrators to build the logical network structures that simplify policy management across the entire organization. We will learn how VLANs are mapped, how network segmentation improves security, and how logical network make administration much more efficient. This module also introduces the Fortinet Security Fabric and explain how Fortinet integrate with the FortiGate firewall and other Fortinet products to exchange information and automate security action. Following that, we will move to the Module 5. Module 5, where we'll study the state-based control. This is one of the most unique capabilities of Fortinet. Every endpoint connected to the network exists in a particular state. For example, registered, authenticated, compliant, quarantined, or blocked. We will learn how devices transition between these states automatically based on predefined security policies. You will see how Fortinet continuously evaluates endpoint status and adjust network access dynamically without requiring administrator intervention. Once we understood how devices move between different access states, we will begin creating the policies that control this behavior. In Module 6, we will see the security policies, which are the core Fortinet decision-making process. Every organization has different security requirements, so Fortinet allows you to translate those requirements into automated policies. You will learn how users and devices are authenticated, how rule-based access control is implemented, and how dynamic VLAN assignment provides the appropriate level of network access based on user identity and device characteristics. We will also discuss policy testing and validation to ensure the security rules behave exactly as intended. Next comes Module 7. In Module 7, which focuses on guest and contractor management, organizations frequently need to provide temporary network access to visitors, to consultants, vendors, or contractors. Instead of creating permanent account or manually configuring network access, Fortinet provides self-registration portals, sponsored based approval workflow, temporary credential, and customized guest portals. By the end of this module, you will know how to provide secure guest access without compromising your organization's security posture. Security doesn't stop once access has been granted. Fortinet also monitoring ongoing activity and respond automatically when threats are detected. This is our next topic in Module 8 and Module 9. Module 8 focusing on security devices integration and automated response. Modern cybersecurity solutions does not operate independently. Instead, they work together as an integrated ecosystem. In this model, we will learn how Fortinet communicate with a product such as Fortinet Analyzer, FortiGate, and third-party security platform. You will see how security event generated by other devices. These devices can trigger automated actions inside Fortinet, such as quarantine, compromised endpoint, or restricting network access without administrator intervention. We will also explore automated workflows that significantly reduce incident response time. In Module 9, we will introduce several advanced Fortinet capabilities. We will discuss advanced profiling techniques, enhanced IoT visibility, operation technology security, high availability concept, and performance optimization of large-scale enterprise deployment. These advanced features become particularly valuable in organization managing thousands of connected devices across multiple locations like branches or different locations. Together, these two modules demonstrate how Fortinet move beyond simple network access control and become an intelligent security platform capable of automated threat response and enterprise scale management. In the last module, we will discuss the visibility troubleshooting and logging. We will see the event monitoring, audit logs and system logs, network troubleshooting tools, communication diagnostic, reporting and analysis. In the last module, Module 11, we will see the Fortinet manager architecture, centralized management concept, distributed deployment management, monitoring and reporting across sites. Before we begin learning the technology itself, I'd like to spend a few minutes discussing the official Fortinet certification associated with this course. Many students ask whether this course prepares them for certification, and the answer is yes. This course follows the objective of Fortinac Administration Certification and is designed to help you build both the theoretical knowledge and the practical skill required for the exam. According to the current certification information shown in the slide, the certification is NAC 5 Fortinac 7.6 Administrator. As we will discuss the next slide, Fortinet has updated certification programs recently, and this certification transitioned to NAC 6 Fortinac Administrator. This exam duration is 65 minutes, and you should expect approximately 30 to 35 questions. The questions are not limited to simple definitions. Many of them are scenario-based, meaning you will need to understand how Fortinac works in real environment and be able to select the best solution for a given situation. Throughout this course, we will explain not only how to configure Fortinac, but also why each configuration is required. This approach will help you both in your daily work and during the certification exam. Besides studying the course material, there are a few recommendations that will significantly improve your chance of success. Although it's possible to pass certification by studying the official material, practical experience make a huge difference. Fortinet recommends that candidates already have a solid understanding of network fundamentals, including switching, routing, VLAN, and access control. In addition, having several months of hands-on experience working with Fortinet is highly beneficial. If you don't currently have access to a production environment, don't worry. Throughout this course, we will build up practical lab scenarios that closely resemble real enterprise deployment. I also encourage you to review the official Fortinet documentation after each module. The administrator guide, deployment guide, and manager guide provide valuable reference material that complement what you will learn here. Remember, certification is not only about passing the exam. It is about gaining the confidence to deploy and manage Fortinet successfully in a real-world environment. Now let's look at an important update regarding Fortinet security program. Fortinet continuously evolving its certification program to better aligning with the current cybersecurity technologies and job roles. As shown on our slide, an important change took place on July 15, 2026. The previous NSA 5 Fortinac F Administrator certification transitioned to the new NSA 6 Fortinac Administrator certification. This change is a part of a complete restructuring of Fortinet certification framework. Instead of the previous 5-level models, Fortinet now organizes certification into 8 NSA levels and groups them into specialized tracks such as secure network, securing operation, cloud security, and SASE. Another important update is that certification now have 2-year validity period, encouraging professionals to keep their knowledge up to date as technology evolves. While the certification structure has changed, the core Fortinet administration skills remain the same. So everything you will learn in this course continue to be highly relevant. Let's see how this transition affects current and future Fortinet certification candidates. The slide summarizes what the certification transition means for Fortinet professionals. Before transition, candidates earned NSE 5 Fortinet F 7.6 Administrator certification. After the transition, the certification is known as NSE 6 Fortinet Administrator under the Secure Networking track. The good news is the Fortinet recognized certifications earned during the transition period. If you pass the Fortinet Administrator exam within the qualifying period defined by Fortinet, your certification is recognized under the new NSA6 framework. And that's the good news. Therefore, when planning your certification journey, always verify the latest certification information throughout the official training institute website to ensure you are registering for the correct exam version. Now we have discussed the certification itself. Let's look at the process of booking the exam. How to book the exam? The first toward becoming certified is creating an account with the Fortinet Training Institute. This account serves as your learning portal and stores your training history, certification, and learning progress. When registering, I strongly recommend using your company email address whenever possible, especially if your organization already works with Fortinet technologies. Also, make sure you remember the email address you are using during registration, because the same email address should also be used when creating your person view account. Using the same email address help you to ensure that your exam results are automatically linked to your Fortinet certification profile. After creating your Fortinet account, the next step is to register with the official testing provider, Person View. Fortinet certification exams are delivered through Person View, one of the world's largest certification testing providers. Your next step is to create a Person View account. Again, it is very important that you use exactly the same email address you used for your Fortinet Training Institute account or your Fortinet account. This allows Fortinet to synchronize your certification record automatically after you complete the exam. Once both accounts are created and linked, you are ready to schedule your certification exam. Let's continue by searching for the correct exam for Fortinac administration exam. After logging into Person View, select Fortinet as exam sponsor, then search for Fortinac administrator certification. Depending on when you are taking the exam, you may see either a Person View NSE 5 Fortinac 7.6 administrator exam or the updated NSE 6 Fortinac administrator exam. Always confirm exam title before scheduling to ensure you are registering for the correct certification version. Person View provides detailed information about the exam, including duration, language, available delivery methods, and scheduling option. Once you have selected the exam, the next decision is how you would like to take the exam. Person View offers two official delivery options of Fortinet certification exam. The first option is to take the exam at an authorized Person View testing center. This provides a controlling testing environment with on-site staff available to assist you if necessary. The second option is on-view online proctoring exam, which allow you to take the exam from your home or office. During an online exam, your identity is verified before the exam begins, and your webcam and microphone are used throughout the session to maintain exam integrity. Choose whichever option best suits your situation and provides the most comfortable testing environment for you. After selecting your preferred delivery method, the next step is scheduling your appointment. Person View will display the available dates for you and times based on your location, selected delivery method. If you are taking the exam as a testing center, you will first choose your preferred location and then select an available appointment. If you are taking the exam online, you will simply choose the date and time that best fits your schedule. My recommendation is to schedule the exam shortly after completing your studies, while the material is still fresh in your mind. Setting a target exam date also provides additional motivation for you to complete your preparation. Version views support several payment methods, including major credit card. Some organizations also purchase exam vouchers through Fortinet authorized training center or through Fortinet partners. After your payment is successfully processed, you will receive a confirmation email containing all important detail about your appointment for exam. Carefully review the confirmation information, especially the date, time, and the exam instruction. If you are taking the exam online, make sure to complete the required system check before exam day to avoid any technical issues. Once you have completed these steps, your exam is officially scheduled. Now it's simply a matter of preparing, and this course is designed to help you do exactly that. Now we have completed the course overview and certification information. We are ready to begin a technical part of our course. The next section we will answer one of the most important questions: what exactly Fortinet and why has it become such an essential component of modern network security? First question and answer: what is the Fortinet? Before I give you the official definition, let's think about a real world scenario. Imagine you are the IT administrator for a company with more than 5,000 devices connected to your network. Employees arrive every morning carrying a laptop, smartphone, printers are connected throughout your building. IP cam or IP cameras monitor the facility. IoT devices are everywhere. In a manufacturing environment, you also have PLC, HMI, sensors, barcode scanners, robots, and many other industrial devices. Now let me ask you a question. Do you really know every single device connected to your network right now or not? Most organizations don't. And that's exactly the problem Fortinet is designed to solve. Fortinet is the Fortinet Network Access Control Solution, or NAC solution. It is continuously discover every device connected to your network, identify what it is, determine who is using it, monitoring its activity, and control whether the device should be allowed to communicate or not. In other words, Fortinet gives administrator complete visibility and complete control over network access. But notice something very important. Fortinet doesn't simply block devices. First, it collects information, analyzes the information, makes an intelligent decision, and then automatically enforces the appropriate security policy. That's what makes Fortinet much more powerful than traditional access control mechanism. Throughout our course, we will see the Fortinet answer the 5 critical questions before making any access decision for your network. Let's begin with the first one. The first question Fortinet asks: where is the device is connected? When a new device connected to your network, the first thing Fortinet wants to know: where exactly did the device enter the network? This may sound like simple question, but it's actually extremely important. Think about a company with 100 of switches and thousands of switch ports spread across multiple buildings. If a unknown laptop suddenly appears on the network and the administrator needs to know the physical location immediately, Fortinet provides exactly this information. It identifies the switch port, the wireless access point, the SSID, or even the VPN connection is being used. For example, instead of simply seeing an IP address like 192.168.10.55, for example, Fortinet tells you the laptop is connected in switch 5, port 18 on the third floor of building A. That level of visibility dramatically reduces troubleshooting time and allow administrators to respond quickly when suspicious device appear. Imagine receiving an alert about unauthorized devices. Instead of searching the entire building, you immediately know exactly where to find it. That's the value of location awareness that the Fortinet provides. Knowing where the device is connected is only the first step. Next, Fortinac wants to know something even more important. Second question, who is using this device? Remember, security decision should not be based only on IP address or MAC address. They should also be based on user identity. Fortinac associated endpoint with actual user and organizational information. For example, the same laptop may be used by an IT administrator today and a guest tomorrow, or another employee after tomorrow. Also, the hardware has not changed. The security policy should be completely different because the user has been changed. Fortinac can identify whether the user is an employee, an IT administrator, an engineer, contractor, a guest, or another type of user defined in your organization. This allows administrator to build identity-based security policies. Instead of saying allow IP address, we can say allow only members of IT department to access management server. That's much more secure approach for your organization. Now Fortinet knows who the user is. It asks another important question. The other important question, what device is connected? Not every endpoint should receive the same level of access. A corporate laptop needs different permission than an IPK. A printer requires different network access than a PLC. A mobile phone should not be treated like a SCADA server. Fortinet automatically profiles device using multiple fingerprinting technique. It examines network behavior, communication pattern, protocol, manufacturer information, DHCP fingerprint, and many other characteristics. Based on this information, it determines exactly what type of endpoint has connected. For example, it can identify Windows laptop, Linux server, IP phones, printers, surveillance solutions like IP cam, PLC controllers, HMI, and many other device categories. This automatic profiling is especially valuable in operation technology environment where many devices do not support traditional security agent. Once Fortinet knows the device type, it can automatically apply the appropriate security policy. But device type alone is not enough. Fortinet also wants to understand the software running on that device. Well, that is the fourth question that Fortinet solved. What operating system and software are running on this endpoint is an important question I have to answer. Because two laptops may look identical from outside, but internally they may represent completely different security risk. One laptop may be fully updated, running the latest version of Windows with antivirus enabled. The other may have an outdated operating system, missing security patches, and no endpoint protection. Fortinet gathers this information about the operating system and security-related application running on the endpoint. It can identify platforms such as Windows, Linux, macOS, Android, and others. The information becomes a part of endpoint profile and help administrator evaluate the device compliance with organizational security policy. Later in this course, we will learn how Fortinet uses this information during compliance check and automated policy enforcement. Rather than making decisions based only on identity, Fortinet also consider health and characteristic of the endpoint before granting access. So far, Fortinet has answered four essential questions: where is the device connected, who is using the device, what type of device, what software running on it. The final question Fortinet asks before making intelligent access decision is when did the device connect and why does the connection time matter from a security perspective? Because Fortinet continuously tracks login time, session duration, connection frequency, user activity pattern, All of these important information is important for Fortinac because for security perspective, user normally, for example, can connect at 8 a.m. from specific location, and suddenly device suddenly appeared in 2 a.m. in a different location. This can indicate a suspicious behavior or a compromised account because the user connected at a specific time from a specific location and device suddenly appears with the same user in a different location and in a different time. Now let's move on to the core capabilities that make Fortinac such a powerful network access control solution. The first and perhaps the most important capability is the network visibility. There is a famous saying in cybersecurity: you cannot secure what you cannot see. This statement perfectly summarizes why visibility is so critical. Many organizations believe they know every device connected to their network. However, once they deploy a network access control solution like Fortinet, they are often surprised to discover hundreds or even thousands of previously unknown devices connected. These might include personal laptop, wireless printer, smart TV, IP cam, VoIP solutions or VoIP phones, IoT sensors, industrial controlling system, barcode scanner, or even unauthorized wireless access. Traditional network management tools typically provide only basic information like IP or MAC address. Fortinet go much further. It's automatically discover every connected endpoint and build a detailed profile using multiple fingerprint technique. It does not simply record that a device existed, it identifies what the device is, where it is connected, how it communicates, and how it should be managed. For example, imagine connecting a new IP cam to a switch. Within a short period, Fortinet discovers the device, identify its IP cam, determine the switch and port where it is connected, records the manufacturer information, and adds the asset inventory. Added to the asset inventory. No manual documentation is required. This complete visibility is the foundation for every other Fortinet features. Without accurate visibility, policy enforcement become unreliable because you don't really know what you are protecting. Once Fortinet discover every endpoint, the next challenge is identifying exactly what each device is. This brings us to the second core capability. That's the device profiling. The second core capability is device profiling because discovery tells us that a device exists. Profiling tells us what that device actually is. The distinction is very important because imagine you are receiving a notification that a new device with a specific MAC address has connected to your network. This information alone does not help much. You still don't know whether it's an employee laptop, a printer, a surveillance cam, or perhaps an authorized device. Fortinet solves this problem by automatically profiling endpoint. It analyzes characteristics such as DHCP information, network protocol, communication pattern, manufacturer details, operating system fingerprint, and many other attributes. Using all of this information together, Fortinet determines the most likely device type. For example, it may identify the endpoint as a corporate laptop, an engineering workstation, an engineering laptop, a PLC controller, a SCADA server, IP cam, or a VoIP phone. Why is this important? Because different devices required different security policy. A printer does not need access to your financial database, for example. An IP cam should never communicate directly with the HR application, for example. A PLC controller should communicate only with authorized industrial system. Accurate profiling allow Fortinet to automatically enforce the correct level of network access for each device category. Throughout this course, we will examine the Fortinac, how it performs profiling, and how administrator can customize profiling rules to improve identification accuracy. After discovering the profiling device, Fortinac is finally ready to make access control decision. Access control decision is based on network access control policy that based on that information what we collect and what Fortinet discovered. Instead of treating every endpoint equally, Fortinet make intelligent decision according to several factors: what type of device, where it's connected, if this device is compliant or not. Based on these factors, Fortinet dynamically determine what level of access the endpoint should receive. For example, an employer corporate laptop may receive full access to production resources. A guest device may be placed into an internet-only VLAN. An unknown device may immediately be isolated until an administrator review it. Unlike traditional static network configuration, Fortinet can communicate directly with switches, with wireless controller, with routers, with firewall to dynamically change VLAN assignment or to apply some security policies automatically. And this approach is commonly referred to dynamic network segmentation or micro segmentation. Instead of manually configuring every switch port, administrators simply define policies and Fortinet automatically enforce them whenever device connect to the network. This greatly simplify administration while significantly improve security. But how Fortinet actually make these decisions? Let's take a closer look about that. Although we often refer to network access control as a single function, Fortinet actually evaluates endpoints through two logical decision processes before granting access. The first is the network access policy. These policies determine where a device should be placed within a network. Fortinet evaluates the information such as user identity, device profile, location, and security rules. And based on these information, based on these conditions, it may instruct the switch or the infrastructure device to move the endpoint into a production VLAN, restricted network, a guest VLAN, or even an isolation VLAN. Notice that administrators do not manually configure every switch. Instead, Fortinet communicate with the network infrastructure and applies these change automatically. The second logical process is compliance and voucher assessment. Identity is not enough. Fortinet also evaluates the health of the endpoint. Is the operating system is up to date or not? Is endpoint protection is installed? Does the device comply with the organization security standard? Let's consider three simple examples. For example, an employee laptop that passes all security check receives full network access. This device, for example, is allowed internet access only. An unknown or non-compliant device may be blocked completely or automatically placed into a quarantine VLAN until the issue is resolved. This combination of identity profiling and compliance allow Fortinet to make intelligent access decisions rather than relying on a static network configuration. Once Fortinet determines the correct policy, the next step is enforcing it automatically. A security policy has no value if it cannot be enforced constantly. This is where Fortinet becomes extremely powerful. Once a decision has been made, Fortinet automatically applies the appropriate security policy without requiring manual intervention from the administrator. Depending on the situation, Fortinet may assign a new VLAN, restrict access to sensitive information or sensitive resources, disconnect a device from the network, or isolate rogue endpoint for further investigation. For example, imagine that an unauthorized laptop is connected to a switch in your organization. Without Fortinet, an administrator would first need to identify the device, locate the correct switch, log into the switch, identify the correct interface, and manually modify the port configuration. This process could take several minutes or even longer in a large enterprise with a large number of switches. With Fortinac, the entire process happens automatically. This device is detected, evaluated against security policies, and the required enforcement action is applied almost immediately. This not only reduces administrative effort but also significantly decreases the time required to respond to a potential security threat. In later lecture, we will configure network policies together and observe these enforcement action in real time within a laboratory environment. So far, we have learned how Fortinac discovers devices, profiles them, determines the appropriate level of access, and enforce security policies. But there is an important question. What happens if the device becomes compromised after it has already been granted access to your network? Imagine a new employee laptop, for example, that successfully authenticated this morning and received full access to your corporate network. A few hours later, the same laptop becomes infected with a ransomware or a malware. If the security team waits for administrator to manually log in to the switch and disable the port, valuable time will be lost. In cybersecurity, every minute matters. That's exactly why Fortinac include automated response, also known as a threat mitigation. Instead of relying on a manual intervention, Fortinac can automatically respond when it receives information about security incident. It continuously listens, for example, for a security event from integrated security platform. When a critical event is detected, Fortinac immediately execute predefined response action. These actions may include moving the endpoint, for example, to a quarantine VLAN, disabling switch port, restricting network access, or isolating the device from the rest of the organization. This important point is the response is automatic and what is called automated response. The important point is that response is happening automatically. Administrator defines the policy once, and Fortinet performs the action every time the defined conditions are met. This greatly reduces the response time and help prevent threats from spreading throughout your network. Later in our course, we will configure this automated response by ourselves and observe how Fortinet react in real time when security event matter. Of course, Fortinet doesn't work alone. To make intelligent decision, it must communicate with other security platforms across the organization. One of the greatest strengths of Fortinet is its ability to integrate with a broader Fortinet security fabric as well as selected third-party security solutions. Modern cybersecurity is no longer based on isolated product. Firewall, endpoint protection, security information, and event management system, access control solution must work together and share information. Fortinet acts as one of the central decision-making component within this ecosystem. For example, if FortiGate may detect malware communication from an endpoint, instead of simply generating a log message, FortiGate sends this information, for example, for Fortinet. Fortinet immediately identifies where the device is connected and is automatically isolate it from the production network. Similarly, FortiAnalyze provides centralized logging and reporting, while FortiSIEM perform advanced event correlation and incident monitoring. Fortinet uses information from FortiAnalyzer, FortiSIEM from these products to make faster and more accurate security decisions. It also integrates directly with the switches and wireless controller to enforce network access policy. Throughout our course, we will see the Fortinet becomes much more powerful when it's deployed as a part of complete Fortinet security fabric through our service connector rather than as a standalone solution. Before we move into the architecture of Fortinet, let us briefly summarize some benefits of we have discussed so far. At this point, you should already understand the Fortinac provide much more simple device authentication. It delivers complete visibility across the network, allowing administrator, for example, to discover every connected device, automatically profiles devices and identify what they are. It supports dynamic network segmentation. It continuously detects rogue or unauthorized device and responds according to organization security policies. And through integration with a Fortinet security fabric, it also supports automated threat containment, helping organization, for example, to respond for security incident much more quickly than manual process. The next part of our lecture, we will study internal architecture of Fortinac. Every Fortinac deployment consists of two primary elements working together. These elements are responsible for discovery, visibility, authentication, policy, enforcement, and centralized management. Depending on your deployment size, these functions may run on the same appliance or in a separate appliances. The first element is the Fortinac server. This is the operational component responsible for day-to-day network access control activity. The second element is the Fortinac Control Manager, sometimes referred as a centralized management platform. In a large organization with multiple sites, often deploy several Fortinac servers managed by a single control manager, which is called Fortinac Control Manager. Throughout the next few slides, we will examine the responsibility of each component in detail and understand when each deployment model should be used. Let's begin with the most important component in every Fortinac deployment. It's the Fortinac server. Fortinac server is the operational heart of the entire Fortinac solution. If we compare Fortinac to the human body, for example, the server is like the brain that continuously receive information, analyze it, make decision, and control the rest of the system. Almost even daily operation take place here. The Fortinac server discover devices, authenticate user, profile endpoint, evaluate policies, control network access, and maintain visibility across the infrastructure. Whenever a new endpoint connected to the network, the server is responsible for identifying it, determining the appropriate level of access. It also communicates directly with the switches, wireless controller, and other infrastructure device to enforce security policies. In short, whenever you think about visibility, authentication, policy enforcement, or access control, you are primarily thinking about the Fortinac server. Now let's look at the first capabilities provided by the Fortinac server. The first capability provided by the Fortinac server is the MAC address mapping. Every device connected to the network has a MAC address, but simply knowing the MAC address is not enough. Fortinac maps each MAC address to its exact physical location within your network. For example, if a laptop is connected to switch 7 port 5, Fortinac records that information. And if the same laptop disconnects from the wired network and later connects through a wireless access point, Fortinac updates its record automatically, and this continuous tracking gives administrator complete visibility into where every endpoint in your network is connected at any time. Second, visibility is a validation assessment. Discovery alone does not guarantee that the device is secure or not. Fortinet can evaluate whether an endpoint comply with your organization's security requirement or not. This is done by using endpoint agent or compliance mechanism. Fortinet can check whether a device meets predefined security standard before granting or maintaining network access or not. Second is a security inspection before allowing someone into a restricted plan. So the user identity is important, but their device must also satisfy the organization security requirement. Besides identifying devices and checking their compliance, the Fortinet server also controls how devices are provisioned and communicate directly with the network infrastructure. The next capability is the network provisioning. Once Fortinet knows who the user is, what device is being used, where it is connected, and whether it's comply with security policies. It can automatically assign the appropriate level of network access according to that. For example, an employee laptop may be placed into a corporate VLAN. A guest device may be assigned a guest network with a network access only, for example. An engineering workstation may be placed into a dedicated engineering VLAN. All of this happen automatically based on predefined policies in Fortinet. The next capability is an infrastructure communication. Fortinet doesn't operate independently. It communicates directly with the switches, wireless controller, and other infrastructure devices. So using supported management protocols such as SMB, SSH, or APIs, depending on the vendor or the integration method, Fortinet can modify switchboard configuration, change VLAN assignment, and enforce access policies without requiring administrator to manually log in to each network device. Finally, the Fortinet server includes database functions. Every piece of information collected by Fortinet is stored in its database. This includes endpoint information, user identities, device profile, infrastructure configuration, security policies, historical event, for example, and much more. All these information are stored in a database like a memory for the Fortinet. Every Fortinet knows about your network, what's information about it, stored it in its database, and continuously updated as the environment change. In addition to visibility and policy enforcement, the Fortinet server also provides several important network services. Like what? Like authentication services. Fortinet supports authentication using local account as well as external identity providers such as Microsoft Active Directory. Fortinet can connect with Microsoft Active Directory. This allows administrator to authenticate user using their existing corporate credential rather than maintaining a separate username and a password. Radius service plays a central role in many network access control deployment, especially when you are using wireless connections in your environment. Fortinet can act as a radius server responsible for processing authentication requests coming from wireless controllers or other network devices. Another capability is a DHCP and DNS service. Also, DHCP and DNS service is another capability of Fortinet. In captive portal or isolation network, Fortinet can temporarily provide DHCP and DNS service for endpoints that have been redirected for registration or for remediation. This ensures that isolated devices still receive basic network service while remaining separate from the production network environment. The Fortinet server also hosts a web service. The administrative GUI interface that we use throughout our course when connecting to the Fortinet is a built-in web service. So administrative user can access the administration GUI through built-in web service. And finally, logging. Logging is very important. Every authentication request, policy decision, device discovery event, administrator action, and system event, all of these is recorded in Fortinet. These logs are extremely valuable when troubleshooting problems or performing audit or investigating security incidents. So far, we have focused on operational component of Fortinet. Now let's look at the component responsible for centralized management in a large environment and what a Fortinet control management exists. The second major component Fortinet deployment is the Fortinet Control Manager. Fortinet Control Manager is typically deployed when an organization has a multiple Fortinet server distributed across different locations. For example, imagine a company with different offices. Every office has a different location. For example, in New York, in London, in Dubai, in Cairo, in Singapore, each office has its own local Fortinet server managing its own switches, wireless controller, and user. Rather than logging into each server separately, administrator can manage all these devices in all locations from a single control manager. The control manager provides centralized administration, policy synchronization, for example, configuration management, reporting, visibility across the entire enterprise. So it's important to understand that the control manager does not replace the local Fortinet server. The server continue performing discovery, authentication, policy enforcement locally. The control manager simply provides centralized management and coordination across all of them. This architecture greatly simplifies administration for large organization with multiple campus or geographically distributed sites. The control manager offers several powerful capabilities designed specifically for large enterprise environment. First one is the network-wide registration. Imagine, for example, that an employee registered on a corporate laptop at the headquarters. Later, the same employee travel to branch office because of all Fortinet servers are synchronized throughout control manager, so the device is already recognized, eliminating any need to register it again. The second capability for Fortinet Manager is the global user identity database. Instead of maintaining separate user record at each location, the control manager consolidates user and device information from every managed Fortinet server, and this will provide administrator with a unified view of users and endpoint across the entire organization. Another important feature is a global version control. Any software update and configuration change can be managed centrally in the Fortinet manager, helping ensure that all Fortinet servers remain consistent and compliant with organization standards. Finally, the control manager support global element management, security policies, logical control, host group, and other configuration element can be created once and then distributed automatically to all Fortinet servers that locate in a different location. This centralized approach significantly reduces administrative effort, minimizes configuration error, and ensures that security policies are applied consistently across all sites. Another important feature is the configuration synchronization. Imagine you are responsible of 10 branch offices, each running its own Fortinet server. Without centralized management, every policy change would have to be configured manually on each server. That approach is time consuming and increases the risk of configuration inconsistency. With a control manager, you have defined the configuration one, and it's automatically synchronized the required setting across all managed Fortinet servers. This ensures that every site follows the same security standard in your organization. The next capability is the scalability. As the organization grows, new branches, new campus, or data center can be added without changing the overall management model. The control manager provides a centralized platform capable of managing large distribution environment efficiently in your organization. Finally, we have a centralized administration. Centralized administration, instead of accessing multiple Fortinet server individually, administrator work from single management interface. Single management interface can administrator manage all different Fortinet server. This simplifies daily operation, reduce administrative effort, and provide a unified view for the entire enterprise or entire large organization. So on brief, the control manager focus of centralized management, policy synchronization, and multi-site administration. Fortinac server performs operational work, device discovery, authentication, policy enforcement, and network control. Now we understand the role of both components. Let's see how they combine in different deployment scenarios. Let's begin with a small and medium size environment. In this deployment, organizations usually don't need separate management and operational server. Instead, one single Fortinac appliance performs both rules. The same appliance acts as a Fortinac server, handling discovery, authentication, profile, and policy enforcement, while also acting as a control manager, providing administration and configuration management. This approach reduces hardware requirement, lower deployment cost, and simplifies management. It's ideal for organizations with single site or a limited number of network devices. For example, a company with one headquarter and a few hundred or even a few thousand of endpoints can easily operate using a single Fortinet appliance. But what happens when an organization expands to multiple campuses or international location? Here we go to the large distributed or multi-site environment deployment. Large enterprises have very different requirements, so they may operate in multiple campus, regional offices, or manufacturer plants, or even in different countries. In this situation, a single Fortinet appliance is no longer sufficient. Instead, each location typically deploy its own local Fortinet server to manage devices at the site. Then all of these servers are connected to a dedicated Fortinet control manager. Think of it like each Fortinet server is responsible for day-to-day operation as its local site. The control manager acts as the headquarters, providing centralized visibility, policy management, reporting, synchronization across entire organization. This architecture offers excellent scalability while maintaining local performance. Even if communication with the control manager is temporarily interrupted, the local Fortinet server continue performing authentication and policy enforcement for its own. This is very useful. This is one of the major advantages of this distributed architecture scenarios. Regardless of deployment size, organizations also need to consider business continuity. So where high availability is very essential and very important. One of the most important design consideration for any critical security platform is high availability, commonly referred to HA. Network access control play a critical role in authentication and access decision. So if the Fortinet system become unavailable, organizations don't want their network operation to stop. To address this requirement, Fortinet support high availability deployment. In a high availability deployment, high availability configuration can be applied. Two Fortinet appliances work together. The first appliance is the primary server. This is the active system that handle all production traffic, device discovery, authentication request, policy enforcement, and administrator configuration change. The second appliance is the secondary server. Under normal condition, it remains in standby mode. However, it continuously receives synchronized configuration, updates, and database information from the primary server. The purpose of secondary server is to be ready at any time to take over if the primary becomes unavailable, if anything happens. Does that minimize downtime and ensure continuous network access control service? Let's see exactly how high availability operate during normal conditions. During normal condition, the primary Fortinet server perform all active functions as I told you. Every administrator login, every policy modification, every discover endpoint, and every authentication request is processed by the primary administrator. At the same time, the primary continuously synchronized important information with the secondary server. This synchronization happens automatically and include the configuration file, endpoint database, user information, security policy, device profile, and network setting. You can think of the secondary server as a continuously updated backup that's always ready to become an active if something happens. This synchronization is extremely important because it ensures that if failure occurs, the secondary server already has all information required to continue operating without requiring administrator to restore backup manually. One common misconception is that administrator should make configuration change on both appliances. That is not correct. All administrative changes are made only by the primary server. The secondary server receives those changes automatically through the synchronization process. This guarantees the consistency between both systems and greatly simplify administration. In a failure scenario, let's now consider what's happening if the primary Fortinac server suddenly become unavailable. This could because of hardware failure, an operating system issue, a power outage, or even a network connectivity problem. Without high availability, all network access control operation would stop until server was restored. That means that a new user might not be authenticated, security policy could no longer be enforced, and administrator would lose visibility into network activity. With high availability enabled, the situation is very different. The secondary server continuously monitor the health of the primary server. If it detects the primary server is no longer available, it automatically assumes the active rule, which is known as a process of failover, because secondary server has already received synchronized configuration file, endpoint information, user data, and policies. It can immediately continue performing the same service. Authentication continues, device visibility continues, policy enforcement continues. From the user perspective, the interruption is either very short or completely unknown. This is why the high availability is considered best practice for enterprise environment where continuous operation is very critical. Now that we have completed the architecture and high availability discussion, let's move on the deployment platform of Fortinac offers. Fortinac can be deployed either a dedicated hardware appliance or as a virtual machine. Let's begin with the hardware appliance. Hardware appliances are a purpose-built in system designed specifically for running Fortinac. Because the hardware and software are optimized together, these appliances provide excellent performance, reliability, and predictable scalability. You can see in the slide the primary hardware models currently available. Fortinac 500 is designed for small environment and support up to approximately 2000 managed devices. Fortinac 600 target medium-sized organization and support significantly large deployment. Fortinac 700 is intended for large enterprise environment with very high endpoint count. Finally, the Fortinac Manager 550 is used when centralized management is required across multiple Fortinac servers. Note that endpoint capacity increase as appliance model increase. Choosing the correct appliance is not simply about buying the largest model, it's about selecting the model that matches the organization current requirement while allowing room of the feature growth. Regardless of the appliance model, all Fortinet hardware platforms share several common enterprise features. Although the appliance models differ in performance and capacity, they all provide several enterprise class features. First, they include RAID-protected storage, which improve data protection and reduce the risk of data loss caused by disk failure. They also include redundant power supplies, allowing the appliance to continue operating even if one power supply fails. Another important benefit is access to FortiCare support service, which provide technical assistance, software update, and hardware replacement option depending on the support contract. One point I'd like to emphasize is the sizing. Fortinac appliances are sized primarily according to the number of network ports being monitored. This includes both physical switch port and the maximum number of concurrent wireless connections. When designing a Fortinac deployment, administrator should calculate the total number of monitor ports rather than simply counting their employees. This ensures that the selected appliance has sufficient capacity to support both current and future growth. Let's now examine each hardware model individually, beginning with the entry-level appliance. For Fortinac 500, this is the first appliance in the Fortinac. This model is intended for small organization or branch offices. It combines both the control server and the application server into one single appliance, making deployment simple and cost effective. It supports up to approximately 2000 monitor network port. Typically, deployment scenarios include branch offices, small offices, small manufacturing facilities, and small educational campus. If an organization operates from a single location with a relatively modest number of connected devices, 500 is often an excellent choice. It provides all core Fortinet functionality without requiring multiple server or complex architecture. Okay, remember also that selecting the correct appliance is always based on sizing requirement, expected growth, and operational needs rather than simply choosing the lowest cost option. As organizations grow, their performance requirement also increase. Let's look at the next appliance in the product family. That's Fortinac 600. Fortinac 600 is designed for medium-sized enterprise environment. Compared to 500, it offers significantly greater processing capability, supporting up to approximately 15,000 monitor network port. This appliance is commonly deployed in organizations such as hospital, university, medium-sized enterprise, and manufacturing facilities, where thousands of endpoints must be managed simultaneously. This environment often includes a mixture of traditional IT devices, wireless user, Internet of Things equipment, and sometimes operation technology OT devices as well. Because of this diversity, the appliance must process large amount of discovery, authentication, profiling, and policy enforcement data without affecting performance. So 600 provides the additional computing resources required for these larger deployment while maintaining the same Fortinet functionality you have already learned about. As we continue through the next slide, you will notice that the difference between appliance models are primarily related to the capacity and scalability rather than the features. All appliances provide the same Fortinet capabilities. The primary difference is the number of endpoints that they can support efficiently. In the next hardware appliance, that Fortinac 700, this is the highest performance appliance designed for larger or very large enterprise with industrial environment. It supports up to 25,000 monitored network port, making it suitable for organization with massive number of connected devices. Think about it like environments such as a large financial institutions, multinational corporation, international airport, large university campus, or industrial companies with multiple manufacturing plants. All these organizations may have thousands of switches, hundreds of wireless access controller, and 10,000 of users, thousands of OT and IoT devices operating simultaneously. In this environment, Fortinet must continuously discover devices, process authentication requests, evaluate policies, and communicate with the network infrastructure without any delays. 700 provides the processing power and memory required for this demanding environment, One important thing and one important point I'd like to emphasize that the functionality of Fortinet remains the same across all hardware models. The primary difference is the capacity, scalability, and performance, but 500 and 700, the software features are identical. Besides operational appliance, Fortinet also provide dedicated platform centralized management, which is 550. Unlike all models which perform network access control operation, 550 is designed specifically for centralized management. Its rule to manage multiple Fortinet server from a single interface. Imagine, for example, a global organization with offices in Europe, in North America, Africa, Asia, Middle East. Each location operates its own Fortinet server. Because authentication and policy enforcement should remain locally, however, the security team also want to single console where they can manage policies, generate reports, synchronize configuration, for example, and monitor the health of every deployment. This is exactly the purpose of the manager 550, and we can notice that the capacity is as described as unlimited. This is because the manager is not responsible for authenticating endpoint or enforcing policy. Instead, it's responsible for coordinating or managing the Fortinet server that perform those operational tasks. Now we have looked at each appliance individually. Let's compare them and discuss how to choose the correct model. As we see, for organization monitoring up to 2000, as I told you, 2000 network port, 500 is generally sufficient. For environment with 2000 to 15,000 port, the recommended platform is 600. For larger than that, 700 provides the necessary processing capacity. Finally, when multiple sites are involved, dedicated 550 manager should be added to provide centralized administration. Okay, now we will go to the virtual deployment option. In addition to dedicated hardware appliance, Fortinet can also deploy it as a virtual appliance. This option has become increasingly popular because many organizations already operate virtualization platform or cloud environment. Functionally, the virtual appliance provide the same Fortinet capabilities as the hardware appliance. The major difference is that the software runs on your existing virtualization infrastructure rather than on a dedicated Fortinet hardware. One of the biggest advantages of virtual deployment is the scalability. The virtual appliance support up to 50,000 endpoint devices, making it suitable for very large environment. Another advantage is deployment flexibility. Organization can deploy Fortinet as on VMware ESXi, Microsoft Hyper-V, Nutanix, or Linux KVM. It can also be deployed in a cloud platform such as Microsoft Azure, Amazon Web Service, Google Cloud Platform, Oracle Cloud Infrastructure, or Alibaba Cloud. This gives an organization more flexibility when designing modern hybrid or cloud-based infrastructure. Let's now examine the component of virtual Fortinet deployment. The first component is FNC CX VM. This is the virtual equivalent for the control and application server. It performs all operational functions we have already discussed, including device discovery, profiling, authentication, policy enforcement, guest management, and overall network access control. A single virtual control and application server can support up to 50,000 endpoint devices, depending on all allocated virtual resources. The second component is FNC MX VM, that is the virtual manager server. Its rule identical to the hardware manager appliance. It provides centralized administration for multiple Fortinet server. According to the sizing information showing in the slide, a single virtual manager can manage up to 100 control and application server. Now let's discuss the recommended virtual machine specification for a small environment deployment. As you can see on this slide, the sizing is intended for environment with up to 2000 monitor network port. The recommendation virtual appliance is the FNC CAVM. Fortinet recommends allocating 4 virtual CPU and 16 gigabyte of memory and 100 gigabyte of storage. These specifications provide enough processing power for device discovery, endpoint profiling, authentication, policy evaluation, and communication with other network infrastructure. Typical deployment scenario and use case including branch offices, small campus, small OT environment, or pilot deployment. As the environment grows, the number of connected devices and authentication requests increase dramatically. Let's see how the resource requirement change. Here for medium environment VM sizing, as we see in our slide. In this case, Fortinet support up to 15,000 monitor network port. Notice how the hardware requirement increase significantly. Fortinet recommend 20 virtual CPU, 32 gigabyte of RAM, and 100 gigabyte of storage. Typical scenarios and use case, as we see in a medium enterprise, university, hospital, manufacturer, facilities. For very large enterprise environment, as we see, we have VM deployment supporting up to 25,000 monitor network board. As we can see, the recommended resource increasing we have 36 virtual CPU, 96 gigabyte of memory, 100 gigabyte of storage. These environments typically include multiple campus, enterprise data center, industrial facilities, or very large operational technology network. Beside all operational server in a large deployment also requires centralized management. Let's see our manager VM. This like a hardware manager. Unlike control and application server, here the manager does not perform endpoint discovery or authentication. It provides centrally administration, as I told you, for multiple Fortinet server, and the recommended specification is 20 virtual CPU, 32 gigabyte of RAM, and 100 gigabyte of storage. This allows administrator to manage multiple Fortinet deployment from a single interface for centralized reporting, for simplifying the backup management, synchronizing security policies across different sites, as I told you before. Now let's move on. Fortinet license. So understanding licensing is very important for you because it determines which features are available within your deployment. Fortinet licensing is based on the number of endpoint devices being managed, and Fortinet offer 3 different license tiers. First tier is the base tier or base license. This license focuses primarily on visibility and basic network access control capabilities. The second is second tier is a plus. Second tier plus, it includes everything available on the base license and add advanced authentication, guest management, onboarding, compliance checking, and additional network access control features. Finally, we will go to the Pro license. There is a Pro license as the most comprehensive option. In addition to everything included in the base and plus, it provides advanced incident response capabilities, event correlation, automated threat response, and security operational feature. Let's begin with the first one, that's the base license. As we see, it provides the core functions required to gain visibility, as I told you, into your network and implement basic network access control. Is designed primarily for organization whose first priority is the discovery and identifying every connected device. best for OT and ICS environment, manufacturer planning, device visibility, microsegmentation initiatives. That's best for base license. What's exactly included in the base license? In the base license, as we see, we have invisibility, network discovery, rogue identification, device profiling, enhanced endpoint visibility, anomaly detection, MDM or mobile device management integration, network access policies, Internet of Things, rogue device detection restriction, firewall segmentation, MAC authentication bypass, and it can be integrated by REST API and reporting. We have a customized report. Not included persistent agent, user authentication, captive portal, full radius, bring your own device, guest management, endpoint compliance, single sign-on, event correlation, and automated threat response. Okay. And a plus license include everything in the base plus advanced identity and access control, best for enterprise campus, university, healthcare, organization requirement, compliance focus, and it has additional features like persistent agent, in a visibility, user access, we have user authentication, captive portal, advanced network access control, we have full radius, bring your own device onboarding, guest management, endpoint compliance, web and firewall single sign-on. In integration, we can have outbound security event, reporting analysis, we have enhanced compliance reporting, audit documentation, but we don't have event correlation, guided triage workflow, automated threat response. These three are not included in the Plus license. And a Pro license that include everything in the Plus and added security operation and automated response capability. We have in incident response features, event correlation, extensible action and audit trail. We have alert criticality, inbound security event, guided triage, advanced security. We have a real-time endpoint contextual alert. We have also security event enrichment, automated containment action. This comparison table simplifies the features comparison between Base, Plus, and Pro. Let's now discuss FortiCare service. Purchasing Fortinac is only the beginning of the deployment lifecycle. Like any enterprise security platform, Fortinac requires some software update, technical support, hardware replacement when necessary, and ongoing maintenance. That's where FortiCare becomes an important thing. FortiCare provides direct access to Fortinet Technical Assistant, commonly known as Technical TAC or TAC. It also gives customers access to software update, security improvement, bug fixes, knowledge base article, and deployment guide. You can think about it as an organization deploying Fortinet across multiple campuses. If a complex integration issue occurs with Active Directory or a third-party switch vendor, having access to Fortinet technical support can save many hours of troubleshooting. Another important benefit of it is access to updated device signatures and software release. In an enterprise environment, FortiCare is generally considered as an essential part of production deployment. Fortinet offers several levels of support depending on the organization operational requirement. The available FortiCare support option are the standard option of 24/7 FortiCare, which provide around the clock technical support whenever assistance is needed. Organizations that require guaranteed hardware replacement can choose next business day RMA, where replacement hardware is shipped on the following business day. For mission critical environment, faster options are available. The 4-hour hardware delivery service, significantly reduce the downtime by delivering replacement hardware within approximately 4 hours. Finally, the highest service level include both 4 hours hardware replacement and on-site engineer support, providing not only the replacement appliance but also technical assistance during installation and recovery. Which service level should an organization choose? It depends on the business impact of downtime. Now we understand hardware, software, licensing, support. Let's see how to select the correct Fortinac solution for a customer or for you. When designing a Fortinac solution, don't begin by choosing a license. Instead, begin by understanding the customer environment. The first step is determining the deployment architecture. Ask yourself, will the customer deploy Fortinet as a virtual appliance, or do they require a dedicated hardware? This is a very important question. For example, organization already that we have already operating VMware or Microsoft Hyper-V often prefer virtual deployment because they can leverage their existing infrastructure. Others may prefer dedicated appliance for maximum reliability and simplified support. Second step is to determine whether a high availability is required or not. If a customer requires continuous operating, every production server should have corresponding secondary server. Remember that high availability effectively doubles the number of server because every active server requires a standby partner. This design decision should always be made before discussing the license requirement because they directly affect both cost and architecture. Okay, once the deployment architecture has been determined, the next question is whether centralized management is required or not. If the customer requires a Fortinet manager or not, yeah, it's simply a question: is this a single site deployment or multi-site deployment? If the organization has only one location, a separate manager is usually unnecessary because Fortinet server can perform both operational and management functions. However, if multiple camps, branch offices, or geographically distributed locations are involved, deploying a dedicated Fortinet manager becomes the recommended approach for that. After determining the architecture, the next decision is selecting the appropriate license. You can ask yourself or ask the customer what they want to achieve. If their goal is the visibility and basic network access control, the base license may be sufficient. If they require user authentication, guest access, bring your own device onboarding, 802 authentication, the plus license is more appropriate. If they want more than that, they will go to the full security operation integration, event correlation, and automated incident response, so the Pro license should be selected. We have now selected the deployment architecture, determine whether high availability is required or not, decide if a manager server is needed or not, and choose the appropriate license level. The next step is calculating the number of endpoint licensing. One of the most common questions customers ask is how Fortinet license is working. The answer is very simple. Fortinet licensing is based on the number of concurrent endpoint devices, not on the hardware appliance. This means that the appliance determines the performance capacity, while the license determines how many devices Fortinet is allowed to manage. On this slide, we have common license quantities such as 100, 1000, 10,000, and 50,000 endpoint. These license quantities can be combined to meet the customer requirement. Look at this example. Suppose a customer has approximately 13,000 endpoint. Rather than purchasing 13 individual 1K license, the recommended approach would be one license with 10K plus 3 additional 1K license. Another example is the organization with 170 endpoint. In this case, multiple license blocks are combined to reach this required capacity. When designing any solution, always remember to leave some space, leave a room for future growth. If a customer currently has 9,500 endpoint and plan significant expansion next year, it is often more cost effective to size the license accordingly rather than upgrading immediately after deployment. Once we have calculated the required endpoint count, the final licensing decision is choosing between the perpetual license and subscription license. Let's begin with perpetual license. Perpetual license means exactly what the name suggests. You purchase the software once and you own the license permanently. Even if your support contract expires, the software itself continues to function. Think of it like purchasing a house. Once you have bought it, you own it. However, if you want maintenance or professional assistant, you will need to purchase those services separately. The same concept applies here. Fortinac provides software update, technical support, device database updates. If Fortinac expires, your Fortinac system continue operating with the license features. However, you will no longer receive any technical assistance, center support, software upgrade, device fingerprint database update, or any new feature enhancement. The alternative license model is becoming increasingly popular, especially in cloud and subscription based environment, is the subscription. Instead of purchasing the software permanently, the customer rent the software for a fixed period. This could be 1 year, 3 years, or 5 years, depending on the purchase subscription. One major advantage is that Fortinac support and software update are included throughout subscription period. For example, as shows a pro license supporting 10,000 endpoint for 36 months, that is 3 years. In this 3 years, the customer receive the complete pro feature set, technical support, software update, FortiGuard service, and continuous maintenance. Many organizations prefer this license model because it aligns with operational budget and simplifies lifecycle management. Rather making a large upfront investment, they pay for the software as an operational expense over subscription period. But the question is, what happens when that subscription period ends? During active subscription period, everything working normally, everything works fine, the license is active, technical support is available, software update continue, new feature become available. However, once the subscription expired, the situation changed significantly. Unlike a perpetual license, subscription license is no longer valid after its expiration date. The customer must renew the subscription to continue using this product. Therefore, when discussing licensing with customers, it's important for you to explain the operational difference clearly as a salesperson. Organization looking for permanent ownership often prefer perpetual license. Organizations that prefer predictable annual operational expense often choose subscription. The correct choice depends on the customer, financial strategy, procurement policies, and long-term operational planning. We have now completed all of the technical content of this introductory lecture. Before we finish, let's summarize everything we have learned today. You have completed the first lecture of Fortinac administration course. During this session, we have covered significant amount of information. We begin by introducing the course, discussing its objective, targeting audience, certification path. We then explore the Fortinac and we learned how to provide complete network visibility, device profiling, network access control. We studied the Fortinac architecture, including the Fortinac server and the control manager, and discussed deployment models for small and large enterprise environment. We also examined high availability, hardware appliance, virtual deployment, resource sizing, license option, FortiGate support, and process of designing a complete Fortinet solution. Understanding all these concepts now will make the configuration and troubleshooting exercise much easier in the upcoming lectures for you. Thank you very much for joining me in this first lecture. I hope now you have a clear understanding of what Fortinet is, why organization deploy it in the organization. Thank you very much for joining me in this first lecture. I hope now you have a clear understanding of what a Fortinet is, why organizations deploy it, and how it fits into modern enterprise security architectures. I encourage you to review today's material before moving on to the next lectures, because the concept form the foundational of everything we will build later. Thank you once again for your time. I look forward to seeing you in the next lecture. Having a great day, and I'll see you in the next session.